We started the discussion of how to increase the capacitance of a capacitor by deriving the formula, talking about how we can increase the area, structure, shape, size, and all of that. Then we spoke of, yes, the space between the plates, they influence. Initially, we spoke of replacing the space with dielectric. Now, what if we replace it with a conducting slab? So, long story short, this is what happens. It will eat up the space, and it will be likely that space has been taken away and the net space is just the difference between them. We are trying to artificially reduce the space between the capacitor plate with the help of a conductor. You will understand this result when you see the final answer. So mathematically, we're looking at E and D being the plate area and the plate separation. So this being D, the area is your surface area. This is placed in vacuum. And a conducting plate, conducting slab of width T is placed in between, right? Placed between the plates. With same area A, right? Okay, next. What happens? So first we know that the electrical field will be from here to here E naught. But we know that the conductor within the space will do what? As electrical field, net field should be 0, right? We know that. So this has to be E naught again. That's nothing but your induced electrical field. Does it make sense? So basically, it is as if you have E naught over here, E naught over here itself, and in between spaces disappeared. And that's what this statement means. Does it make sense? I'll show the math. So first few basic stuff. So we know that C naught. So normally without any slab and all that, that's your capacitance of a capacitor. Then E naught is your constant by epsilon naught, and this is Q by A by epsilon naught. And your voltage is E naught into D initially. So QD by A epsilon naught. I'm just listing things which we might end up using. Now, voltage between the plate after placing conducting slab. What happens? Well, we saw that E into D will encounter opposing force, which is E naught into T, right? That's your EP, is it not? We know that voltage, I wrote it here, right? Voltage is nothing but E into D, force into displacement. Again, unit with regarding to unit per unit charge and all of that. So this being the normal formula, this being the initial minus this is your opposing force. So difference between them will give us the net voltage, right? We have to explain this in detail. There is a voltage that appears across the slab, but opposite in polarity, right? One more reason, the a conductor has no net electrical field inside it. For this to happen, the plates, in this case slabs, surface has to be same potential. So basically, this is what it means, E naught into T. It should be so. That's what we're trying to tell. So your V is equal to E naught into D minus T. But E naught according to this formula is what? Q by A epsilon naught D minus T. So we finally have the result. We know that C is equal to Q by V. So if we transpose and all that, if I transpose this and that, simple math, T minus T. But we want to see how much of the capacitance has increased. So I'll multiply and divide with D, because C naught is epsilon naught A by D. So we don't have a D in the denominator. To do that, we have multiplied and divided with D. So this will give us C naught divided by C naught D divided by D minus D. So that is the amount of increase that we will see. So basically it will appear as if the middle space has disappeared. The space between the plates have disappeared. That's what this statement meant. So there's an artificial reduction in the space between the plates. It's like it's there, at the same time it's not there. To conclude, the introduction of the conducting slab of thickness T in a parallel plate capacitor increases its capacitance by a factor of D by T minus T. So if you guys are interested, one step more, for D is equal to T. What does it mean? The slab is touching the plates. What happens? C will be equal to undefined, because it will be divided by 0. So the capacitance of the capacitor increases exponentially. So it becomes a connected wire, but basically, right guys? Anyways, that was for your interest. So this is what happens when you place a conducting slab between two parallel plates of capacitor.